Okay, now we discuss how to draw the absolute value function and write in the piecewise function. Okay, given the absolute function f(x) equal to absolute x. So absolute x, this absolute x we can define in two functions. For x more than 0, fx equal to positive x. For x less than 0, we get fx equal to negative x. Okay, how we get these two values? We can try to draw and by using the table. Okay, let's say x equal to negative 2, we get fx equal to negative 2, absolute negative 2 equal to 2, absolute negative 1 equal to 1. When x equal to 0, we get fx equal to 0. Okay, for fx equal to 1, we get fx equal to 1. For x equal to 2, we get fx equal to 2. So when we draw, for x equal to negative 2, let's say negative 2 here, fx equal to 2. For x equal to negative 1, let's say here is negative 1, fx equal to 1. For x equal to 0, fx equal to 0. Okay, then for x equal to 1, fx equal to 1. For x equal to 2, fx equal to 2. So we get these two lines. Okay, this right line is symmetrical with respect to the y-axis because this line mirror to the left line. So this absolute function is even function. Okay, to write in piecewise function, for x more than 0, okay, for x more than 0, when we go to the right side, x more than 0, fx equal to value x, positive x. For x equal less than 0, left side, fx equal to negative x. Example 3.8. Draw the graph of a periodic function fx equal to x times absolute x for x from negative pi to pi. Then find its Fourier series. Solution. Use the definition of absolute function. The function fx is defined as fx equal to x times absolute. So we can split to x times positive x and x times negative x because absolute x can be split to negative and positive. Positive on interval 0 to infinity and negative from negative infinity to 0 because in the question want us to find the function interval negative infinity to infinity. So we split from 0 to infinity and negative infinity to 0. Okay, from here we expand. X times positive x, we get x square. X times negative x, we get negative x square. And then we draw this graph. From 0 to infinity, from 0 to pi, we get this shape, quadratic graph, x square. And then from negative infinity to 0, from negative pi to 0, we get the maximum shape, quadratic, negative x square. Okay, then we identify the even and odd function. Okay, because this graph is symmetrical with respect to origin. That means when we rotate this graph 180 degree, we get this bottom graph. So symmetrical with respect to the origin. So this graph is under the odd function. Okay, After we identify the graph is odd or even function, we determine the type of Fourier. So because the graph is the odd function, therefore we use the Fourier sine series. Under Fourier sine series, A0 is equal to 0, En also equal to 0. So we only find Bn. Okay, the summation from 1 to infinity. This is the Fourier sine series. Fourier sine series given as fx equal to summation from 1 to infinity Bn sin n pi x over L. Okay, E0 equal to 0, En equal to 0. Okay, so we only find Bn. Bn equal to 2 over L, 0 to L, fx sin n pi x over L dx. L equal to pi because 2L equal to 2 pi. How we get this one? From pi, 2L equal to pi minus negative pi. So equal to 2 pi. From 2 pi, we identify L. L equal to pi. Okay, so substitute L equal to pi. From 0 to pi, replace L by pi. Fx, okay, from 0 to pi, fx is equal to x square. So substitute x square here. Sin n x, because L equal to pi, so cancel out, you get sin n x here. So to integrate x sin n x, we can use tabulate integration by pi. By using tabulate integration by pi, u is equal to x squared, dv equal to sin n x. Differentiate x squared up to 0. So first differentiation, differentiate x squared equal to 2x, differentiate 2x equal to 2, differentiate 2 equal to 0. So we differentiate 3 times, 1, 2, 3. So this side we need to integrate 3 times 2. So from sin nx, integrate first time, we get negative cos nx divided by n. And then from here, integrate again. Integrate negative cos equal to negative sin, because integrate cos equal to positive. This negative carry, n divide and then multiply by this n. So we get n square. Integrate negative sin. Integrate sin equal to negative. Negative negative equal to positive. Integrate negative sin nx equal to positive cos nx divide by n. So n times n squared equal to n cube. And then put this sign, start with positive. So write alternately positive, negative, positive. And then multiply diagonally. X squared times positive times negative cos nx over n. 2x times negative sin x over n square. 2 times positive times cos nx over n cube. And then we find the summation of these 3 terms. So put inside this bracket x squared times positive times negative cos nx over n, we get this term, plus 2x times negative sin x over n squared, we get the second term, plus 2 times positive times cos nx over n cube, we get the third term. Okay, next substitute by pi, then substitute by 0. Okay, when we substitute by pi, substitute x by pi, we get pi squared over n cos n pi plus 2 pi over n squared sin n pi plus 2n cube cos n pi minus substitute x by 0, 0 here, 0, x equal to 0, 0, 2 over n cube cos 0 equal to 1. So we get 2 over n cube here. Okay, now we try to simplify this expression. Okay, pi squared over n cos n pi carry here. 2 pi over n squared n pi. Okay, sin n pi is equal to 0. So cancel this term. 2 n cube cos n pi carry here. Minus plus, so minus bring here. Okay, negative pi squared over n cos n pi plus 2 over n cube cos n pi. These two terms we can combine. Okay, so and then we also can take out the n. Here we have n, so we can bring forward n. Okay, we have negative, positive, negative. So the negative we can take out. We put here negative. So this value will be positive right here. Pi square. This one, we already take out the n. So leave it n squared inside. So the final answer for Bn is negative 2 over n pi, 2 n squared from here, plus pi squared over n. Okay, n we already take out, so we get pi squared here. 2 over n squared cos n pi. Okay, so the final answer, the Fourier sine series is defined as summation from 1 to infinity Bn. So this is the value of Bn, sine n x.